Welcome to Nobility Learning Center. Today, I will present to you about rates of chemical reaction. Uh, Contents of this lesson are reaction rate, graph of rate of reaction, preconditions for a chemical reaction, factors affecting the rates of chemical reaction, and effect of catalyst on the rates of chemical reaction. Okay, these are the contents of this lesson. Learning objectives define. At the end of this lesson, students will be able to define rate of reaction and describe rate of reaction using a graph, list the preconditions for a chemical reaction to occur, explain how collision, activation energy, and proper orientation of reactants cause a chemical reaction to occur, and explain the effect of changes in temperature, concentration, or pressure and volume. Uh, Introduction. What is chemical kinetics? First, define the word chemical kinetics and rate of chemical reaction. Okay, chemical kinetics is a branch of chemistry which study about the rate of chemical reaction and reaction mechanisms. Okay, every chemical reaction proceeds at different rates or speed. Some reactions proceed very slowly and may take a number of days to complete, while others are very rapid, requiring only a few seconds to occur. What is rate of a reaction? The rate of a chemical reaction measures the decrease in the concentration of a reactant or the increase in the concentration of a product per unit time. During chemical reaction, the concentration of the reactant becomes what decreased because reactants disappeared, reactants consumed and used up during chemical reaction. But products are what? Appeared, produced, or formed. This means that the rate of a reaction determines how fast the concentration of a reactant or a product changes with time. The rate of reaction is obtained by determining the concentration of reactants or products using a reaction. Rate can be measured by the change in mass of the reactants or products, the change in pH, change in conductivity or ion production, the change in color or intensity of color, change in temperature, and production of a gas. Okay, generally, the rate of a reaction can be obtained by measuring either one of the above changes in properties of substances, consequently relating to changes in their concentration during the course of reaction. Rate of reaction is equals to the change in concentration of substance divided by the change in time. R mathematically expressed as R equals to change in C divided by what? Change in T. R represents the rate of chemical reaction. Change C represents the change in concentration of reactants or products. Change T represents the change in time. Rate is inversely proportional to what? Time and directly proportional to concentration. Graphically expressed as rate of chemical reaction uh, can be expressed graphically just like this. This is the concentration of what the reactants gradually decreases when the reactants are what disappeared or consumed during chemical reaction. As the concentration of the products increase, as the concentration of the products increase, the concentration of the reactant becomes what decrease. Okay, rate of reactant equals to slope divided by g. This the blue line indicates what? The tangent line, which is the slope. Okay, change in c divided by what? Change in c. What are the preconditions for a chemical reaction? Chemical reactions are usually explained by the collision theory. What does the collision theory mean? Okay, the collision theory, according to the collision theory, reactants must be collide to produce the desired product. The reactants must be effectively collide to produce what? The desired product. Okay, if there is no collision, we will not get the desired product. Okay, the assumptions of the collision theory is that chemical reactions takes place due to the collision between molecules. Collision theory states that for a chemical reaction to occur, the reacting particles must collide with one another. Okay, these are the three preconditions that must be fulfilled. A chemical reaction to be what occur. Okay, the first one, the first precondition is collision between reactants. Second, proper orientation, and the third one is activation energy. Collision between reactants. There are what two kinds of collision. The first one is effective collision, and the second is ineffective collision. This is according to what the collision theory. Effective collision means a kind of collision in which the reactants are effectively collide to give the desired product. Okay. Ineffective collision is a kind of collision in which the reactants are not effectively collide and they are not give what the desired product. Next, what is activation energy? Activation energy is the minimum amount of energy required for the reaction. It's the sufficient amount of energy to break the bonds in the reactants and form new bonds in the product. The third one is proper orientation. Collision of molecules with sufficient activation energy will not bring reaction if the reacting molecules are not properly oriented. Okay, thus the collision between molecules should have the proper orientation to undergo chemical reaction. Let's see this example. Consider the reaction between hydrogen and chlorine to produce hydrogen chloride. Okay, according to the collision theory, okay, there are what three preconditions. The first precondition is effective collision, the second proper orientation, and the third is activation energy. Okay, this is hydrogen atoms or hydrogen molecule combined with chlorine molecule to produce what hydrogen chloride. Okay, in which all the particles of hydrogen, all the atoms of hydrogen are not properly oriented and they are not effectively collide. Okay, look at this, the collision between what? The two molecules, hydrogen molecule and chlorine molecule. Okay, this is caused by what? The reactants are not properly oriented. And this causes what? The effect of this is ineffective collision. Okay, ineffective collision. The reactants are not effectively collide. Okay, all the hydrogen atoms are not effectively collide to produce what the desired product. Okay, so therefore the reactants are not properly oriented. They are not effectively collide. This gives us what? No product. Okay, there is no reaction between these particles or these molecules. And the second one also is the reactants are not properly oriented. Okay, this one is hydrogen molecule, this one is chlorine molecule. They are not properly collide. Okay, because the reactants are not properly oriented and there is no reaction. In the third reaction, the atoms or the particles of hydrogen are properly oriented with what? The particles of chlorine. Okay, both atoms are properly oriented and they properly collide. just like this one, okay, properly chloride, and they give the desired product, which is hydrogen chloride, okay. Factors affecting the rate of chemical reaction. There are what 5 factors that affect the rate of chemical reaction. The first one is the nature of reactants, and second, temperature, third, concentration of reactants, fourth, surface area, fifth is catalyst. How can these 5 factors affect the rate of chemical reaction? Okay, first, the nature of the reactants affects. How can the nature of the reactants affect the rate of chemical reaction? The rate of reaction is influenced by the type and nature of the reacting substance. Okay, for example, the following reactions have different rates due to the nature of the reactants. Okay, there are what different kinds of elements in the periodic table. Based on their activity, elements can be classified as what? Active metals, inactive metals, active nonmetals. There are also what? Inactive or inert nonmetals. Okay, based on this, magnesium and iron are what? Active metals. They can react with what? Hydrochloric acid, but copper is inactive, cannot replace hydrogen. Okay, therefore, the reaction between magnesium and hydrogen chloride is a very fast reaction. Okay, a very fast reaction. The desired product will be obtained within what? Microsecond. Okay, but the reaction between iron and hydrochloric acid is a slow reaction. It takes what? A minute. It takes what? Uh, an hour or in a days. Okay, even in a days. But the reaction between copper and hydrogen chloride gives what? No reaction. There is no formation of product because copper is less active than what? Hydrogen. Therefore, the nature of naturally magnesium is more active than iron. Iron is more active than copper. The next factor is temperature. An increase in temperature increases the rate of chemical reaction. As the temperature increases, the average kinetic energy of the particles increases, which in turn increases the number of effective collisions. In general, for many chemical reactions, the rate of a reaction doubles for every 10 degrees Celsius rise in temperature. Okay? As the temperature raised by what 10 degrees Celsius, the rate of reaction increased by what double. In most chemical reactions, in some chemical reactions, the rate of the temperature may not be what affected, but in a few chemical reactions, the temperature, an increase in temperature decreases the rate. A decrease in temperature increases what? The rate. For example, the reaction between magnesium and water. Magnesium reacts with both hot and cold water. But magnesium reacted with what? Cold water is fast. Magnesium reacted with what? Hot water. This is what? Slow chemical reaction. The third factor is concentration of reactant. The number of collisions is proportional to the concentration of reactants. The higher the concentration of the reactants, the more collisions between the reacting particles, and thus the higher the rate of the reaction. The fourth factor is surface area. An increase in the size of particles decreases the surface area and a decrease in the rate of chemical reaction. A decrease in the size of particles means the higher the surface area of reactants and the faster is the rate of the reaction, because more contact results in more collisions between each small particles of what reactants. The fifth factor is catalyst. A catalyst is a substance that changes the rate of chemical reaction without itself being consumed in the reaction. Okay, for example, uh, the decomposition of potassium chlorate, KClO3, into KCl and O2 is made faster in the presence of MnO2 catalyst. Okay, potassium chlorate, KClO3, is decomposed in the presence of manganese dioxide and heat to produce 2KCl and 3O2 in the presence of MnO2. Okay, there are two kinds of catalysts. Catalysts that speed up the rate of chemical reaction by slowing down the activation energy is called what? Positive catalysts or promoters. Catalysts that slow down the rate of chemical reaction by increasing the activation energy is known as what? Uh, Negative catalysts or inhibitors. A catalyst speeds up the rate of a reaction by providing an alternative reaction path with lower activation energy. Lower activation energy for a reaction corresponds to the higher reaction rate. Okay, this is a chemical reaction. That is what catalyzed and uncatalyzed chemical reaction. Okay, these are reactants. These one are what? Products. Reactants give products in the absence of what? Catalyzed. In the absence of catalyst, take has what? Longest path. The longest pathway. Okay, longest pathway. But reactants gives products in the presence of catalyst with the shortest pathway. Okay, because activation energy decreased in catalyzed reaction and activation energy increased in uncatalyzed chemical reaction. Okay, thank you for watching. Thank you for watching. See you next time. Please don't forget to like, comment, and subscribe. Thank you very much.